Okay, so you study the immune system, evolution, and anthropology. I understand there's more than one immune system, actually.
Yes, so you can break up the immune system in a number of different ways, but one of the biggest divisions is between the innate immune system and the adaptive immune system.
And how long have both of those been there?
Well, the adaptive immune system, there's been several versions of it that we believe emerged before 125 million years ago.
Which is pretty recent, really.
Well, yeah, in terms of geological time, that is pretty recent. So there's a version that emerges emerges sometime before cartilaginous fish, like sharks, and there's a version that also emerged sometime before lamprey and hagfish.
So it's a vertebrate thing?
Yes, more or less a vertebrate thing.
Okay. But the other immune system, the innate immune system, how far back does that go?
It's back, as far back as you can go.
Billions of
Billions
years.
of years, single
so
cellular
10
life.
times older.
Oh, very far, yeah.
Uh-huh. So what's the difference between the adaptive immune system and the innate immune system?
Well, so apart from being very ancient, the innate immune system operates without memory. So it's an inherited, it tends to be a very generalized response. It sees very broad, molecular patterns of invading pathogens, and it recognizes mainly non-self. That's its job.
So something that's non-self comes into you, and if the innate immune system is prepared for that, it goes after it.
Yeah. If it can see it, it goes after it. It's also, so its main techniques, right, by which it does this is by barriers, so skin, mucosa, phagocytosis, so cell eating, cells that professionally eat other cells, and also inflammation. So inflammation plays a big, big role in innate immunity.
So inflammation is mainly a part of the innate immune system.
Well, both immune systems use it, but it's a powerful, powerful force in innate immunity.
So this one can't remember anything. You have an infection with something and it fights it successfully, and next time it's the same thing.
Yeah, there's a phenomenon known as tolerance, which could be thought of technically in a similar way. If you're exposed to one antigen over and over again in increasing amounts, the innate immune system kind of becomes numb to it. It doesn't respond as strongly.
Sounds like the opposite of what you might want.
Well, yeah, but the innate immune system is also highly reactive and can be very damaging. So it doesn't really care that there's just about killing a single foreign thing. The cytokines, the proteins, the inflammatory proteins it releases to kill something will kill anything. So innate immunity, when it becomes overactive or is just very strong, can kill lots of surrounding tissue. So it can be quite damaging. So tolerance would be potentially adaptive.
So is the adaptive immune system more targeted then?
Yeah, so the adaptive immune system is like a sniper-like response.
Uh-huh.
So for it to work, it has to be educated by the innate immune system about the threat. But once it sees a threat, T cells and B cells will clonally reproduce themselves once they see one
So that's
specific
getting complicated.
Sorry.
Does the innate immune system conduct classes for the adaptive immune system? What does it do?
So the innate immune system, cells within the innate immune system, like macrophages, neutrophils, dendritic cells.
These are different cells,
these are different
in
cells
the immune system.
Right, that belong to the innate immune system, will eat foreign things and then present them on their cell surface.
So they grab pieces of things that are bad and show them to the other part of the immune system and says, go after this stuff.
Yeah, exactly. Little strings of proteins from any one given thing that it eats. So if it eats a cold virus, it'll present little strings of proteins from that cold virus.
So if you've had measles once, what goes on is that one part of the immune system presents this to the other part of the immune system that it remembers.
Yeah, so the T cells and B cells are, if they see it, so if they see it when it's presented, they clone themselves over and over again to target that thing, and they will make memory cells in the process. So those cells will continue to circulate long after the infection is passed.
I'm guessing that there are all kinds of subtle secret warfare mechanisms that have evolved. Let's go on in just a minute to talk about the tricks that bacteria and viruses might use to evade these attacks.